In this video, we're going to talk about functions. We have spoken a lot about functions. We have reviewed the basic characteristics of functions. Now, we can see what happens to these properties when we combine functions in different ways, using basic mathematical operations to create new functions. For example, if the cost for a company to manufacture X items is described by the function. So let's say it's described by the function C of X and the revenue created by the sale of X items. So the revenue, let's say the revenue created by the sale of X items is described by another function, which is, let's take it to be R of X, right? Then the profit on the manufacture and the sale of X item is defined as P of X should be equal to the R of X minus the C of X, right? So using the difference between two functions, we can create new function. Another alternative way is we can create function by composing two functions, right? What do we mean by this? Let me use an example here. So for example, given the function maybe f of x should be equal to x squared and g of x should be equal to maybe 3x plus 1. Now the composite function, which is maybe j dot f dot j, can be defined as, or can be defined such that j dot or f dot g of x will be equal to f, then you open brackets, then the g comes inside this big bracket, then of x, then you close the big bracket, squared, right? Because we have the s squared here, right? So with this one, what is g of x? Let's put g of x into this box here. So with this one, we're gonna get f of, what is g of x? G of x is 3x plus 1. So we put that inside. So x plus 1, then squared, right? Very simple. So from here you can just what do we call it? We can just simplify it and you get your answer, right? Another way is the composite function. Let's say we have this one, not f dot g of x. Let's say we have maybe g dot f rather. So the g is rather here and the f is, we just swipe it. Let's see what we are going to get from that. Let's see if you're going to get the same thing or different function altogether. So with this one, we can get something like j dot f into bracket of x, which will be equal to, so the j comes out with a big bracket of f, then of x in the small bracket, then the big bracket closes. So with this one, let's put f of g inside this bracket, right? So with this one, we are going to get 3 multiplying f of x plus 1. That's what we are going to get. Then when we do it, we should get 3x squared plus 1, right? So we can see that these two functions are different from each other. That's what we are talking about. So with this, what we have talked about here, we are going to talk about combining functions with mathematical operators, right? Now, to combine functions using mathematical operators, we simply write the functions with the operator and simplify it. So given two functions, let's use f and g here. We can define 4 new functions, right? So let's look at the first one. We can have f plus g of x, which is equal to f of x plus g of x. Now this is the sum. This is sum. Now let's take another function. So let's say we have f minus g of x. This can be equal to f of x minus g of x. Now you can see that this is difference. this difference, right? Now let's take another one. Let's say we can have something like f dot g of x. This one can be equal to f of x then g of x. What is this? This one is product. You can see this one is product. Let's see the last one. We can have something like f on g of x, which is equal to f of x on g of x. Now for this, g of x should never be equal to 0. So what will be this? This one will be quotient, right? You can see it from there, right? So these are the four new operators that we can get, right? Now let's use some real examples here and solve something, right? So let's say I'm having the function. I'm just gonna choose a random function and use to solve a real example. So let's say I have the function of, okay, maybe f of x should be equal to 2x minus 3, and g of x, let's choose maybe s squared minus 1, right? Now for each of these functions, we are going to state the domain. We will state its domain, and then we will find a, maybe f plus g of x. Let's find this one first and see the next thing that we can do. Now for this one, let's see what we can do here. So for this, what is f of x? So this, we can write this as f of x plus g of x, right? So what is f of x? So f of x is 2x minus 3, right? Plus g of x is what? S squared minus 1. So we have this, right? Now when we combine it and simplify, we can get, so 2x plus this, so we have 2x minus 3 plus s squared minus 1. Then we'll get s squared plus 2x then minus 4, right? So what is the domain for this function right here? You can pause the video and try to state the domain for this function, and let's see. Now let's continue. Now the domain for this function will be in the interval of, so the domain will be negative infinity then positive infinity. That will be the interval. It will be in the interval of negative infinity to the positive infinity, right? Now let's look at the second one, b. Let's try to find the difference. So that will be f minus g of x, right? So with this one, we can also state it as f of x minus g of x, right? So when we do it like that, what is f of x? So we know that f of x is 2x minus 3 then minus x squared minus 1, and when we do it, we should get negative s squared plus 2x minus 2. And what is the domain for this one as well? What will be the domain? Guess. So this one will be, the domain will be in the interval of negative infinity positive infinity, right? Then let's look at the third one. So the third one, let's find the product. So okay, let me just clean this one, right? Okay, so let's find the product for this. So that will be f dot g of x, right? So with this one, we can also write it as f of x g of x. We are just multiplying, so we have 2x minus 3 multiplying s squared minus 1, and when we multiply it, we should get 2x cubed minus 3x squared minus 2x plus 3. And what will be the domain for this as well? Who can guess? You can guess. Try to pause the video and guess the answer. So the domain for this one will also be in the interval of negative infinity then positive infinity here. So that's a finite. So We also have the last one. Let's look at the last one. That's the quotient. Let's find the quotient for these functions. So we have f on g of x, right, which is f of x on g of x, where g of x can never be equal to 0, right? So with that, let's solve it and see. So we have 2x minus 3 on s squared minus 1. What will be the domain for this? This one is very, very simple. This one is very simple to do, right? So the domain of this function, you just take the denominator right here. So we have the denominator, which is s squared minus 1 equal to 0. You just equate it to 0. Then s squared should be equal to 1. S should be equal to plus or minus 1. So therefore the domain is x is such that x should never be equal to plus or minus 1. So this will be our domain. Very simple to do. Very, very simple to do. So thank you for watching the video. In our next video, we'll talk about function composition in detail. Thank you.